Okay, I'm going to start a bit like earlier on, just because I want to be sure that I mention my ex-boss, which is Dr. Alan Reynolds. Alan was working on phytomining for his PhD a million years ago. Now, he's not that old, but a very, very long time ago. And he actually got me very much interested in this idea of plants gathering metals, specifically in mining areas. Then afterwards, we actually started developing the whole idea of getting the metals out and generating nanoparticles, which is an high value products. So fundamentally giving back value to retired mines, which in the UK is actually a very, very good point, because obviously there was a very, very long history of industrial heritage, which is excellent. So I did archaeometallurgy as a PhD, and the whole thing came together that way. So about 2 years ago, actually the summer during COVID, in reality, we started developing the idea of having a citizen science project. So we put adverts out there in Gardening magazine of people being interested in trying a set of seeds that we put together in order to see if we could accumulate metals, what was the threshold in which these plants were working, etc., and what was like the difference in metal concentration in soil in urban, suburban, and other areas. So the guys from the Barnsley heritage group here got in touch with us and said, okay, let's give it a try. And so they planted the plot actually at the entrance of the site over there. It was like just 1 meter by 1 meter. They planted our seeds and everything else. So that was very interesting. And in the citizen science approach, what the citizens had to do was also to dig a bit of soil before and after they planted the plants, and we could check the metal enrichment or not, I mean the metal presence in the soil. And so they did, and they also had to send us the biomass. And then we noticed that actually the metal enrichment in Barnsley was very interesting. So it's not contaminated, but is actually quite an interesting concentration. So we thought that it could be a very good place to have a pilot site to work on, to see what type of plants we could get to work, how long it would take to actually get all the metals out from this soil, the excess metals out of these soils. Could we regenerate the soil, increasing the nutrients in it? So we applied for a Women in Innovation program from Innovate UK, and for this project that is called Resilient Nature, and we got the award. So I'm one of the awardees of this year, and we started this pilot here in Barnsley and one in Salford. So two completely different sites, one retired mine and the other one an industrial site, and see what type of plants will actually grow better, what was happening with the metals, etc. So this is for like sort of our park where we can play and actually try different plants and combination of plants, which plant likes each other, which plant doesn't like each other, what happens with the weather. We was very dry this year, so a series of experimental work on a real soil instead of being in a polytunnel where we can obviously add our metals, but it's not the same. And that's what we are doing at the moment. So this project itself will finish at the end of March 2024. Started on the 1st of April and finish at the end of March. And we have been doing the first 6 months of trial, which were very interesting because they showed that commercially available plants could increase the amount of accumulation quite nicely on their own. So they are adjusting fundamentally to the type of soil, and they would increase of 1 order of magnitude. So from 100 milligrams in 1 kilo of biomass, they could get to 1,000 milligrams. So they actually increase very nicely, and all this data are from Barnsley. Within the project, we also met a jeweler, and she is used the first metal harvested from Barnsley to actually make a jewel for the young jewelers in Berlin, I believe. I can tell you the exact name of the exhibition, but anyway, there is a Barnsley footprint somewhere else in Europe to show the first metals from here, so that's kind of really good. So fundamentally, I mean, all around here there are all the residues coming out from the coal. So obviously, coal was taken out with the neighboring rocks, let's say. So once you take out the coal and you start processing, all the residues there are more enriched in metals compared to a normal rock like a limestone or something like that. Of course, that doesn't have any coal. So in this case, it would like interesting amount of titanium, chromium, and that in our mind is like, okay, what if we could recover this metal? Because it would be too low amount in order to do a proper mining, but if you work on phytomining, which is a very low capital investment type of technique, and it doesn't have a negative impact on the environment because obviously you're using plants, then you can start recovering this interesting amount, which is not extremely significant, but it is quite a good amount to actually be recovered. So that was the idea. So it has higher concentration compared to a normal agricultural land. It's not too high, but it starts being of economic interest if we can have it as nanoparticles. So that's what made it interesting. Okay, so what we're doing here is fundamentally, we did a first design of the phytomining garden. I quite like the miner's garden is called here. So it was plants that we analyzed here first, and we saw the Barnsley local plants. Fundamentally they grow wild here, and we saw some of them were promising, so they had more metals. So we harvested them and then we replanted them on this side. And then on the other hand, there were actually plants that were in the literature known as phytomining or hyperaccumulator plants, but they were UK locals. So we planted all of them. So what we do is that we come monthly, we take samples of the plants, and then we harvest and we put them in a processing tank where we can actually extract the metal, which is local. So we do everything on site, and then we see which plants have suffered and which plants are still going fine, and if there's some of them are suffered, we remove them. Like today we were removing the thistle, for instance, and we plant new plants that can actually develop during the season. So for today we are actually planting the winter garden, so we started planting heathers and pansies and primroses that could continue during the winter, because we had, for instance, corn that obviously is not going to be in season, nasturtium which is not going to be in season, so we're kind of changing the season at this point in time, and then we will check what is continuing and what is not continuing. But so every month we'll do exactly that. So sample all the different plants, then harvest everything together, put it into processing tank, and then check and change the plants if required, or reseed the same plants if we see that they were working fine. We did some trial on industrial plants here as well, like camelina, for instance, which is used to make oil. Obviously edible oil, but can also be as industrial oil to do biopolymers. So we saw if it was resistant to metal-enriched soil, which it was. So we got to start developing that type of planting as well, so we can use the byproduct also in symbiosis with other industries in the UK, which would help a different type of manufacturing industries, which is the idea. We were actually lucky enough to obtain another funding from Innovate UK within the permanent magnet coal. So the new project is called Phytoray. Is going to start phytoremediation, phytomining of rare earths, and it's going to start on the 1st of November. So we will continue here. So we planted some plants already, ferns that actually really like rare earth. We did an evaluation of rare earth in this site. It's a relatively small amount, but we want to see if we can actually gather them with the plants, targeting them specifically. So that will be a one-year project again. And we also were awarded another Innovate UK project from the Design Foundation, and that's called Rethinking Phyona. So the main thing is that obviously we use plants, so as a first approach you think it's not going to be affecting anybody because you're using plants, right? Fine. However, you never know in reality what's happening. So what we want to do, that's a 6-month project, and is mostly related to human-centered design and planet-centered design. So we're going to have colleagues from Brunel, Dr. Eugene Pei, which will go work on the human-centered design. So we'll have focus groups with users of the landscape to understand how much something like this could affect them. And we try to use biodiversity as much as possible, of course, but what do we need to change? What do we need to rethink in our approach in order to ensure that all the users are happy with it? And then the other side is the Planet Center, so we're going to have a life cycle assessment of the whole process to understand if it is carbon neutral, carbon negative, or carbon positive. If carbon positive, of course, we need to see what we need to change in order to make it carbon neutral so we don't affect the environment in a negative way. So that's also going to start in December, and so we have like the next year quite busy in Barnsley, so that's excellent.
I would like to say I just fell into it, which seems to be the way things happen in my life. But after my PhD, which concluded in 2019, I worked for a period as a science officer in Brunel University, and that's sort of when I met Lorna Angolano, and she sort of started explaining this project to me. At first we were sort of looking at contaminated grass, which was found in old Welsh coal mines, and this is how phytomining was brought to me, and this is how I sort of got into this project. She asked, do you want to collaborate on a couple of things? Do you want to do things like this? And yeah, that's how it happened. Yeah. My thesis was on a biomimetic approach to synthesizing basically functional materials like titanium oxide, which is a known photocatalyst for decontamination and for formulating drug delivery devices. So basically it's using a biomimetic approach to try to solve a lot of current and functional problems. So it was an interesting project. So as part of the project, we're sort of trying to understand how different plants actually survive based on changing of the season. So now we're going from summer to much colder months. So we have to start looking for different plants that are able to cope with the colder weather, the possibility of frost, a slightly wetter winter period from now on to spring next year. And at this point in time, we've found a couple of plants which we believe are phytoremediators, and we're trying to see how well they will cope in Barnsley. So we're changing the plants. We sort of like a changing of the guard. We're changing the plants from the spring summer variety to much more winter hardy plants to see how well they cope. I think this is quite important because if you're trying to make phytoremediation a sustainable and reasonable part of soil remediation in the whole of UK or world round, you have to be able to understand the different mechanisms of the climate, of the individual regions. So you have to make something that's more individualistic. So that's what we're doing. We're making something individualistic for Barnsley. For the summer variety, we're working with quite a lot of different grasses, so things like agrostis, the scampia, basically any sort of grass species we're looking at. And as well as trying to fulfill the function of remediating the soil, we do also want to make sure that the garden that we're planning is actually something aesthetically pleasing, something that you can look at, something that's biodiverse, and something that just brings a sense of, I don't know, happiness just observing it. So while it's doing its work, it looks good and it's contributing in multiple ways. So we're trying to sort of engineer a mixture of plants that, while they fulfill this functionality, they also look good. So in terms of summer, spring variety, we're looking at a lot of things that actually flower quite well and have the ability to change color depending on the metal concentration or the different metals that are present in there. So we're still changing, because this is still like a pilot program. A lot of the plants that we started with, it's not the plants that we have now. So we're still changing. We're trying to see which survives and which is the best to move forward with. And yeah, if you plan for plants to have to be able to cope with a spring that has the normal amount of rainfall, and the season suddenly changes and it's a bit drier than usual, then you probably end up compromising the growth of the plants, the germination of the plant, and you have less thriving of the species, which means that in their role as a soil remediation device, they won't be able to cope properly. So you need to be able to anticipate the seasonality and the possibility that maybe as the year goes by and as climate change becomes more of a bigger issue in Europe and the world around, you have to be a bit more flexible and in adding species that are able to cope with just any eventuality. So we did learn quite a lot from Barnsley this year, and the fact that we actually have to start looking at plants that are able to cope with drought, which is something we never thought we'd be thinking about in this area of the UK. So this was our sort of first pilot project, a lot of things that we're looking at is basically the plant selection and the effects of the season on the plants itself. So going on forward, we have to start actually taking things into consideration as to how the weather can really affect the plant selection, and we need to probably start planning on using plants that are a bit more resilient in terms of, I don't know, water scarcity or higher than average sun, higher than average temperature and things like that. And additionally, we did find that because the sites are not really that big, if we're supposed to expand this operation, or if this is supposed to become more of a commercially viable means of soil remediation, you have to understand that you probably need a bit more personnel to deal with to deal with sort of planting, to deal with sowing, to deal with weeding, to deal with a lot of different manual aspects of actually trying to grow a thriving soil remediation type of garden.